Numbers are irrational numbers. They are irrational numbers. For example, pi, this is irrational number. Although we used to say that it is 22 upon 7. If we use this, then it is of this type. It should be rational number, but it's not exact representation of this pi. This is not an exact. This is an approximate representation of pi, right? If you look at the calculator, you can see over there that there is no such integer which is repeating there. So this is not an exact value. This is an approximate value. So pi is basically, if you look at the circle, this is the diameter and this is the circumference, c. So c, circumference of the circle, is directly proportional to the diameter. And if we remove this sign of the proportionality, we use here pi. This is constant of proportionality, because in fact between the circumference and the diameter. Okay, and this is irrational number. Similarly, under root 2, under root 5, or under root 3, these are the irrational numbers. Then combination of rational, and these irrational numbers are denoted by q prime. So then we have q and union q prime, means the combination of rational and irrational. This is denoted by set of real numbers. This is set of real numbers, and the graphical representation of the set of real numbers is basically a line. From minus infinity to infinity, there is some 0 over here, 1 over here, 2 over there, and there are infinite number of points or infinite number of rational or irrational numbers between 0 and 1. Okay, so this is a continuous line. This line is representing the set of real numbers. Remember that minus infinity and infinity is not included in the set of real numbers, right? So this is, in fact, this is an open interval which is representing the set of real numbers. So open interval means we are considering all the points between minus infinity and infinity, excluding these two. Whereas a and b, for example, this is an open interval, so we are considering all the points between a and b, excluding a and b. And then we have closed interval a and b, that means we are including these two numbers as well. So the representation, if this is a and this is b, and if we draw a small circle around this a small circle around this a, b, then open interval means all these points here, whereas closed interval means we are including these points as well. Okay. Another way of writing the open and closed interval in the set form, it is the set of all points such that it is lying between a and b. This is another way of writing the open interval. Then we have, in fact, these things are prerequisite for the complex analysis. Real advanced calculus and real analysis is the prerequisite. So I would just recalling the things. I do hope that you know already all these things. And if we have closed interval, we have this thing in the set form. This is closed interval. So we are considering all those points which are less than or equal to x, and x is less than or equal to, sorry, a is less than or equal to x, and x is less than or equal to b. Then there was an in ancient time